Alright, draft physics video. Half a day response, sort of. Won't put in the usual category because it wasn't quite as rude, but and it's more on just this one subject, so we'll take a pass on making it a series video. But anyway, so find the video and increase the speed, of course. Half a day, yes, I already did. Okay. Alright, so just thought I would, I should bring up a couple of points first, so maybe I'll do some drawing first. So I need to move this camera up to here, I think that'll work. We'll hope. Alright, so one thing on interferometer. So he's later in this video is going to say that I don't even think interferometry works. I just don't think it works the way you think it works. So it works, but it works in a much different way. I think the mirror has to move, so to speak, for it to work, quote unquote. And it depends on the kind of light that's being used. I think the light needs to be pulsed, frankly. I think it was in the original Michelson-Morley experiment. And that makes a huge difference. Like the idea of fluorescent lights being at 60 cycles, or I guess 40 cycles in England. I don't know what the cycles there is. But anyway, and that bleeds through, and so that's really the frequency they're measuring the difference in. So it's a lot less precise than measuring the difference between photons at 500 nanometers, for example. So, so I should reduce the Michelson-Morley thing to its simplest terms. You basically have an emitter, and then you have a receiver, and then you have a receiver again. And the idea is you send the light there, and you send the light back, and somehow you're going to detect some sort of difference in time between going this way and going this other leg. Now, the one that's moving in this, saying the idea is the experiment is moving in a direction. So the direction would change this distance, and it wouldn't change this distance. Say if the direction was this way. Okay, so you can see this distance doesn't get changed, but this distance could be. The simple argument I've attempted to make in different ways and with limited success is that it's really just about the two mirrors. Okay, so and they're going to be the emitter and the receiver. So the original emitter shoots the light. So just think of it as the beam splitter, okay, is really going to be the emitter. And what happens is if this is point 0 in time, when you release the photon, let's say, then what's going to happen is this mirror is going to move in that time. And it's going to move a certain amount. Let's just call it 0.8, just for the sake of argument. That's how far the mirror moves in this much distance. And so it's going to move away 0.8. And so it's going to lengthen the path by 0.8. And then the idea is you reflect it back and forth and back and forth and back and forth. But the idea is that all those back and forths are going to do exactly what this does. So it's not going to change anything. And then what happens is as it reflects, and so this is now the new point 0, right after the reflection, this thing is going to move closer by exactly that same amount of 0.8. 0.8 minus 0.8 is 0. So in fact, every part of the experiment that matters has actually moved the same amount of distance, and so the photons will travel exactly the same amount of distance as the ones that travel this way. So in that sense, it can't work to detect motion of the experiment. It's a failed idea because the distance is exactly the same. Alright, now the other argument is about the idea that, as I'm stating, if you have pulsed laser or pulsed light, so like ultraviolet light would be pulsed light. Well, even an incandescent light is pulsed light because of the fact that they frequency is changing. And so it has that frequency in the light. It's in there. And so that would be the frequency you could measure the difference between those pulses of when the light's on and off. And you're not really measuring the nanometers, which would be a tiny, tiny frequency underneath that. So it's again, we're back to carrier waves and frequencies like with the radar experiment. So it gets a little bit complicated, but at any rate, the idea of detecting these differences, I'm saying, is perfectly valid if your mirror moves. So if the mirror is moved by vibrations from the world, and the vibrations hit this mirror more than they hit this mirror, then that will create a difference, and you'll see that phase difference. And that's detectable. So I've never said interferometers can't work. I said they can't work to do this measurement of space-time. That's what and I said they can't work to do this. You can't do this light thing. You can't do this tiny nanometer, this 500 nanometer distance change, unless you have all the photons, all the light is being emitted. Each photon is emitted at exactly, they're all in phase with each other. That is, every ray, so these are all rays of light, every ray of light has exactly the same phase. They're all on phase. Now that's what they try to do. That's everything they try to do with their laser at Ligo, is to try to get all of the rays of the laser beam to be in phase. They don't care about how fat it gets. They don't care how much it spreads, diverges. Any of that stuff doesn't matter. The stuff that matters is getting them in phase. And that's logically would be important for you to be able to use the phase of the photons to do your measurement. And that would be the ideal, because that's a very small wavelength. Very small wavelengths can detect very small changes in distance. Alright, so my first argument is Michelson-Morley can't work to detect motion. The second argument is when they did Michelson-Morley, they weren't measuring phase differences in the photons at the nanometer scale. They were measuring the phase difference between the pulses of light created by the device that was producing the light. Was a pulsed device, I would contend. But anyway, alright, so that's enough for now, I suppose. So we'll go to the video. So I just make it clear, I think interferometers can work. But see, the trick is, if all you're measuring is the vibration of the mirror, okay, then distance doesn't matter. Distance is now irrelevant. A 2-inch interferometer, a 10-inch, a 500-inch, all the same. Actually, the smaller you make it, the more accurate it's likely to be. Less chance of interferences and whatnot. So the length of the interferometer wouldn't make a difference. Now the only difference it would make is clearly it'd be very hard to move this mirror if they're very close together and not move the one on the other leg. So you have to have a minimum distance of a foot or something just to get the two legs far enough apart from each other so one of them doesn't feel as much of the vibration as the other one. But that's it. That's the reason why you have length in these arms, and you could even put the arms going the opposite direction from each other. If you're trying to, it would make it directional, because then a noise coming from this direction would be even more detectable, because this mirror would move so much more than this one, the one that way. So there's no hard and fast. I'm just saying there's different ways of applying the technology and detecting different levels of sensitivity, but they're based on different premises, and the premise I say can work is the one where the mirror actually moves. The one I say is nonsense is the one where space is created between photons. or even between the source mirror and the other mirror. You know, I don't I don't buy it, but I don't buy it for a lot of more complex reasons. You know, this just isn't good enough light. Well, you know, it is what it is. Let's see if I can. Let's just do a quick test. Is that any better? Nah, it's still kind of fuzzy. Yeah, I guess I gotta come up with a plan. I guess I have to go back to the bigger, the light table. Yeah, anyway. See, there's pulsed light. See? So you can pulse light, and then you can tell the difference between the pulses. You know, the peaks, whether they're the same intensity. Okay, so we will move along. I should really get this brighter. Yeah, it's brighter, but not much brighter. Anyway, yeah, it's blurry too. So maybe it's too close to the camera now. All right, never mind. I'll fix that. Technical issues are, you know, inevitable, probably. So, on to the videotape and such.
Okay. Remember the question? Why 2 mile arms on the Ligo experiment? Yeah, 2 mile, whatever. 1 mile. 2 mile round trip, 1 mile round trip, whatever. Long arms on the Ligo.
Yeah, well, it shouldn't be a whatever subject, but I think the actual thing is 2.4 kilometers. No, 2 kilometers. I think is accurate.
I go up into barometer.
Which is 2.4 miles or something like that.
Remember, won't like this answer, but this is the answer. This is the answer according to.
Yeah, look, it's not really not about what I like. I'm trying to get to the bottom of it. Okay, it's like the two slit and the other stuff. You make claims, and there's all these different people saying different things are happening, and they're making these different descriptions. So we're right back to, you know, Feynman just drawing the, oh, here, this is what the single slit does. It just makes a lump, and this other single slit just makes a lump. These aren't accurate descriptions, and I'm saying there's something fundamentally inaccurate. And even Feynman, a Feynman quote is something like that, right? I mean, if you can't explain it to your grandmother, then you probably don't know what you're talking about, or something like that. Well, why not the accurate description of the frickin' thing, and then the inaccurate one? Why all these different descriptions of the phenomenon?
Orthodox theory.
You know, it's almost insulting to the word orthodox to call it this orthodox theory when, you know, you do have all of these people doing many worlds, string theory, holograms, you know, and then Copenhagen radar tons. You know, to call this any kind of, you know, like there's an orthodox here to be found. They're fundamentalists. They're not orthodox.
If you have a broken ruler, my ruler is spot on, accurate. Your ruler is 1 micron too long.
Okay, so what he's getting to is that his argument is the mirror doesn't actually move. And if it does move, it moves because the photons move it. The actual laser beam gets longer and therefore pushes the mirror because the space has made more space in between the photons. So his argument is essentially that in between the 2 points of the legs, oh, can't do drawings when he's on the, yeah, I have to switch. No, this shouldn't take too long. Wow, that's really blurry. Okay, but anyway, maybe I'll just draw. Well, it's good. You can see it. It's not great, but okay. So here's the distance. So what he's saying is the photons will actually each wave of the photon. So whether you draw them like I would draw them, or you draw them like you would, which is this kind of crap. So your frequency, I'm just saying the peak is where there's a ton. The trough is where there's no ton. But anyway, it doesn't matter. So here's your wave going in. He's saying the wave is being stretched. Okay, so now the wave is is basically red shifted, and that's what they're detecting. So what's happening is the photons red shift because more space gets interjected between them. I'll exaggerate it a little. So the original pattern was like this, and when the gravity wave comes through, it somehow puts more space between the photons, and then it takes space away. So it gives more space and it takes space away. So they red shift and then they blue shift, and then they red shift and then they blue shift. And because they're shifting, there's more of them, that means they must push the mirror a little bit in that direction and then push it back somehow. I don't know how they exactly pull the mirror. So now we're getting to the pull argument. Gravity is supposed to be a pull force. How come all of a sudden it's doing this push stuff? But anyway, so yeah, I find that explanation inconsistent with the argument that this gravity radiation was radiation, because you can't make radiation do that. And you could almost argue that if they actually see they take away all the volume of the mass, so total big giant suns are turned into little tiny specks. So you probably can't, but see the little speck there? That's what they do to giant things. Now you could almost argue that if the three solar masses were big, really big solar masses, and you made them just disappear from the universe, so you destroyed matter, just pulled it out of the universe, that somehow the space would fill the void and therefore stretch everywhere. So you could sort of say, yeah, I can see where if I pull matter out of the universe, I could make space go whoop, and fill the void, and that somehow, could create a wave of whoop, but I certainly couldn't make it go wop, back out again, and So now they're creating, this is like this, creation and annihilation events all over the place. So, I mean, one of the basic axioms, that you can't create or destroy this energy stuff is sort of being blown up all over the place now. It's kind of becoming just routine to just say, fuck that idea. Fuck the idea that events actually have to take place in the right order in time, and you can somehow borrow from the future. So they're doing that. We can borrow from the future, grab some matter, throw it into the past, and then when we get to the future, we'll throw it back out because we borrowed it in the future. So they're breaking fundamental laws like the consistency of the linearity of time, and now this idea of matter and energy being things you can just create and destroy anytime you want. That seems to be also something they just really couldn't care less about anymore. And I think that's a mistake. Yes, I do. I do think that's a mistake. An error.
Okay, so on a standard 12-inch ruler, 300 millimeters, let's say the 300th millimeter is 1 micron too far, and that's a cumulative error of having each millimeter, evenly, having an inaccuracy in each millimeter, just accumulated. Now your 300 millimeter ruler is 1 micron.
Yeah, so the point is, I think it's just easy just to say that the ruler's broken in the sense that you've redshifted it. You've taken every Planck constant of distance and made it a little bit bigger, and that adds up over a distance to a lot of little increases in space. And so the space that's getting increased in this experiment is the space of the photons. The distance between the photons is stretched somehow. Now, if we say the space in between the mirror and the emitter, that gets kind of messy, because why wouldn't the space be stretching already everywhere? Even before the emitter. So the emitter would be being pushed, forward then. You could argue this the space between the emitter and wherever some other point on Earth also got stretched and pushed. So then the emitter would have gotten pushed forward, and it creates the same problem with the interferometer. And then your mirror would have gotten pushed forward, so everything would have stretched consistent with that stretching, and then you wouldn't be able to detect the stretch. So the stretch really has to be in the photons, I think, logically.
I come along. Now, you and I can design fitted wardrobes and tile our floors of our house, and we'll never know that your ruler is 1 micron off. But if we...
Well, we will if we can see the redshift. So if we had the benefit of being able to see the frequency that comes off of it, then we would know, oh, that frequency is 498, and it's supposed to be 496.
were to decide to tile the Tibetan.
But that wouldn't even work either, because you can't. Yes, because now when you lengthen it, time is also expanded, and therefore to have the same measurement, you have to cut the edges off because the time has to be the same. So as you stretch it, you have less photons in the same amount of time.
Plateau, yeah, and we were to survey it and mark it out, some great huge chess square perhaps, or it occurred to me that this could be a solution perhaps to global warming. Let's tile the Tibetan Plateau with white tiles.
I don't see how that would work at all, but whatever.
Anyway, imagining it being a very specific dimension, you could imagine then that, say, I'm going to tile this rectangular side and you're going to tile this rectangular side, making square side. Over those great distances, the cumulative error might mount such that in the end, my tile is, how best to do this? My tile is there, and your tile, there's going to be an overlap when the tiles meet. They're not going to meet flush because of the cumulative error.
Right. So I think that's easy enough described as shift. You're just shifting the photons, red shifting them, and then blue shifting. Red shifting and blue shifting. So the mirror is not the issue. It's the photons themselves that are traveling through the space, and the space is expanding, and therefore, see, the problem with this is then you could argue the whole Earth is expanding, and then you could argue as the Earth expands, that would increase the distance from the emitter to the mirror. So, it gets kind of complicated, doesn't it? I'm saying that obviously this one's like like when you start getting into the relativity crap and you go through all this stuff about what each photon is doing and what's happening to the rest of the universe at the same time as the photon's progressing, you really do have to go through this detail by detail. But I'm saying I think there's room for an apparent inconsistency here, in the sense that have they accounted for that? Have they accounted for the fact that this gravitational wave actually expanded the whole Earth?
So, now how does that translate to Ligo? A gravitational wave, in essence, in orthodox science, in general relativity theory, breaks rulers.
Well, if people would just admit that all this is about is your broken perception, and that there is no general relativity that has anything to do with the real world, it just has to do with broken perceptions. Rulers. Your perception is a ruler. Your clocks are rulers. The clocks break. Nothing else broke. But I would clearly say that if you're using like a muon as a clock, it's a broken clock if you're moving it, because it decays at a different rate. That's not a incredible explanation. That's a very credible explanation. And you keep talking as if somewhere in your science or in your theory you've demonstrated how that's an incredible explanation, that it's not reasonable to speculate that atomic decay would be affected by velocity, when it's perfectly reasonable.
And thus, the minute effect of these gravitational waves, I guess this is why they say it's akin to measuring, um,
Well, it's akin to, they'll say that if at 2 miles they're measuring a proton, then they can extrapolate that to any distance and say, well, it's the number of protons times the 2 miles. So whatever has a billion protons in it, that would be the billion distance, and that could be Alpha Centauri or whatever. And so a billion protons would be the thickness of a human hair. So it doesn't have anything to do with actually detecting human hairs on fucking Alpha Centauri. It's just a crazy extrapolation in a sense, because they haven't built an interferometer that's 200 million light years long.
a hair on Pluto or something. Um,
Yeah, I wish it was just Pluto. you know, it might be something closer to realistic, but no, it's Alpha Centauri.
isn't detectable in short distances. The wavelengths only become out of phase with each other after the aggregate effect. Okay, so
Yes, right. So I agree that if you're correct that that's how it works, okay. But as I pointed out, that also is affecting the thing emitting the photons, and it's affecting the thing, the mirror is also being moved. So you still haven't explained how the movement of the mirrors and the movement of the emitter don't compensate, especially on a round globe planet that's also expanding, um, for any change, any redshift in the photons.
so when we build some Morley interferometer, we simulate and move the mirrors to gain interference purposefully.
Yes, well, to calibrate it, you move the mirrors to put the light at phase, so then you can tell that there's a difference between the two mirrors from some new noise that's going to be created. So yes, you have to zero it to cancel out all the noise, what you can of the noise, and you put them on phase. So, but again, I said that in the previous video, so I don't. You should just say yes, you're right. They calibrated. Well, maybe he says that.
But in the Ligo experiment, and it is true, we don't, the lengths will not be exactly the same in number of wavelengths, and neither do they need to be. The importance is the shift over a long length. But in Ligo, if you listen to the documentaries, it's all about not moving the mirror. Okay? And the gravitational wave, the principle isn't that the gravitational wave hits it and wobbles it about. Yeah? The principle is that space is.
Well, okay, I'm just saying that that's not how they describe it. All right? So when I go to the Wikipedia page, I don't think that's what they're going to say. But anyway, we'll see. But clearly, I've heard it described, even the 60 symbols people, I can go back to them. And there was implications that the mirror is doing the moving. So I'm just saying I don't think there's much consistency in how this is explained. And what you're basically saying is the thing that's moving are the photons. They're moving away from each other. The distance between the wavelengths is changing. So if there's a corpuscle element, the particle element of the photon, if I could say that, of its duality, the particle part of the duality is separating.
Changed. And that is akin to breaking rulers, which has an aggregate effect of, the phases might seem to be in line, but over the long distance, you see that the peaks and the troughs go out of alignment.
Right, but now my argument is how does radiation do that? So it's not really radiation, right? It's not pure energy. How does pure energy do that? How does it move across a field of photons? Let's say the photons are moving and the radiation somehow is moving faster than the photons, right? Because the photons are on their way back, maybe. They're coming back at the wave. I mean, obviously when the photons are moving, the wave has to be moving the same way as the photons, in the same direction. So there's sort of a little bit of a problem, isn't there? Because the wave is supposed to be going the same speed as the photons, and yet somehow it's going to go faster than some of the photons. Somewhere in there it has to. Right? So I don't know. That sounds paradoxical. Sounds paradoxical that it could ever actually change the distance between two photons when it could never catch up to two individual photons.
No. Well, this is problematic.
So I guess it would have to happen exactly when the photon is emitted, because that's the only time the wave could actually jump in and catch the photon, the distance between the wavelength. The only time it could adjust the wavelength is it would have to do it right when it's being emitted.
Explanation within DraftScience, because as I understand it, DraftScience actually refuses to believe the principle of interferometry.
Okay, so see, that's his understanding. So I'm just saying, maybe you'll concede that you don't have a very deep understanding, because clearly I've never denied the fact that if you move mirrors in one arm and you don't move the mirror in the other arm, that you're going to be able to detect the differences. If you have something, a frequency of some kind to measure, whether it's 60 cycles a second, or whether it's 500 cycles a second, or whether it's 1500 cycles a second, pulsed light. So it's important. I think pulsed is what kind of light is being used, but regardless, or let's just say you're saying you have a detector fine enough to detect the nanometer difference, just a few nanometers in difference.
It even works, but
I'm arguing it doesn't work the way you say it works, and it doesn't work for the purposes you think it works for, like detecting the fact that the light is moving, the Earth is moving, and therefore the Earth's movement has somehow changed the path length the light will have to travel, when it can't really do that, because each individual photon will travel exactly the same amount of distance in both arms.
So it would be
And the only one that might be suspect actually is the other arm, not the arm moving with the movement, but the arm not moving. The perpendicular arm is the one a little bit suspect, because the angle of the mirrors. The mirrors are angled, and when you move an angle, you change where the photon hits. If it hits here, it's a longer distance. If it hits here, it's a shorter distance. So that gets a little dicey, and that's sort of actually a result found in Michelson-Morley, was he actually did find a difference, and it was exactly the opposite of what he wanted to find. He was expecting to find. It was in the wrong place. And it might have been in the wrong place because the only arm that actually was changing was the arm perpendicular to the movement. So another point from my side, maybe.
erroneous and in error to try and figure out how LIGO works, because the very principle of interferometry he denies works.
So again, you asserted it twice, first as I believe, and now you just asserted it as a fact. So it's not a fact. It's a garbage argument. What I'm saying is there's maybe three technical levels of mechanics that the instrument's working on. The idea of changing the distance between things, the idea of what changes that distance. The emitter, which you're sort of arguing, because the wave hits the emitter, right when the photon's being emitted, is the only point where it can actually change the distance. So it changes the distance right there at the emitter. Or you change the distance because the mirror wobbles. And then I've already gone into the whole problem with the idea of your interferometer guts, which is the beam splitter. That's really a diffraction gradient, which creates its own problems in terms of the two paths don't have an equal amount of divergence.
But given that he tries to understand how LIGO works, what what you can't do because of the
Well, yeah. Well, I'm just saying. I don't think you people understand it. Frankly, I really don't, because I don't think you've thought about the consequences of the principle you're saying is in place here. You're saying there's a principle that's happening, and the people are using words like a radiation moving the speed of light. There's a consequence to this idea of your radiation changing all of the photons in your ruler. It can't do that.
principle of complementarity, which is a firm principle in quantum mechanics and reality of.
So again, he's he's saying this is firm this, firm that. There's no firm anything in quantum mechanics, frankly. Like I said, you've broken the idea of annihilation and creation events. You've broken the whole fucking idea that events has to happen in the right sequence and time. There's no rule you give a shit about. So in my opinion, that's just such empty words in the history of this conversation, where we find out that there are no principles that you physicists won't break for the purpose of creating, just somehow justifying your broken mathematics.
What has become orthodox science, quantum mechanics, the principle of complementarity says, look, there are wave phenomena and there is particle phenomena.
Well, no. I mean, again, you want to just pretend that that's the truth. I'm saying, no, there's principles. Huygens either happens or Huygens doesn't happen. Heisenberg is either true or Heisenberg is false. You can't be arguing that, well, in certain experiments Heisenberg is true and in certain experiments Huygens is true. No, the underlying mechanisms are decidedly correct or incorrect as descriptions of reality. And that's what I'm challenging, your descriptions of reality. So if you're going to say, I just choose a different description of reality depending on what experiment I'm doing, then I'm just going to say that's the definition of crap science. That's junk. That's garbage. You either have a principle and defend it, or you admit your principles are uncertain and you really don't know how the universe works. Just admit you don't have the answer. Don't say I can plug in any premises, any axioms I want, depending on the philosophical conversation I'm having. It's just bullshit. So call it complementary. We get to make up the rules for every game we're playing. I mean, it's just bullshit. If we kick really good, then we're playing soccer. If we throw really good, then we're playing baseball. You just change the rules based on what you happen to have, a piece of fucking gibberish formula that fits. And that's it. So I'll just plug in any bullshit premises and bullshit formula, to suit my purposes. That's not fucking science. That's not rational, for fuck's sake.
If you set up your apparatus looking for wave phenomena, don't try to talk about how it works in terms of particle phenomena.
Well, again, I didn't do that. So, this argument that somehow I rigidly forced it to meet my standards. No, I drew the wave and I said, look, this is my understanding that each one of these peaks is actually where the photons are. But it's irrelevant. Let's just play with their wave. So I didn't break your wave theory. I didn't deny its function. I'm trying to find out what you think the truth is so I can say, well, look how your truth contradicts itself. Look how your truth hasn't accounted for all of these variables. You still haven't accounted for any explanations of all the gibberish they come up with for the two-slit experiment. You haven't accounted for all the lensing phenomenon that doesn't exist and should by your own statement about what gravity's doing. You have 500 500 light year across lenses, and you have no explanation for why the lens only works here and it doesn't work there. It only works way out here. It doesn't work in here. No, it only works out there. That's bullshit. Gravity doesn't work that way. Gravity doesn't create gravity at Pluto and no gravity where the Earth is. How does gravity, where's the example of gravity anywhere in the universe where there's no gravity where the Earth is, okay, in spherical gravity, okay, because your lensing is spherical. Don't deny that. Your images have spherical trails, so that you can't deny this, and you have it on both sides. that plenty of lensing images with the stuff on both sides. So you can't deny you're obligated to defend spherical lensing, and that's the same as spherical gravity. So go ahead and show me the example in nature anywhere where you have gravity at the surface of at the body creating it, no gravity where the Earth is, and strong gravity where Pluto is. Because that can't frickin' happen.
That's what science is trying to do, speaking in terms of describing.
So again, I'm just saying, go watch the last video. That's not what I was trying to do. I didn't force my particle theory onto any of this conversation whatsoever. I drew it as waves. I drew it as in phase. I used the words of the wave philosophy. So again, just a canard, just more bullshit to sit there and say somehow I broke the conversation by breaking their rules that I have to argue in your park. I argued in your goddamn ballpark. I played by your goddamn rules, and yet you're claiming I didn't. That's how much of a liar you are.
For interferometry as measuring the speed and distances of pulses. Well, it's not designed that way. There are no design features.
Okay, so it's exactly designed that way. Okay, it's exactly designed to tell the difference between the pulses. If you don't think light is at a 400 nanometer pulse or a 700 nanometer pulse, that's exactly how it functions. That's exactly what a wave is. That's if I draw a sine wave, somebody can call that quite logically a pulse. That's what a pulse will look like in the encyclopedia.
Which correlate with that explanation. The design features which correlate with an explanation correlate with looking for cancellations and frequency.
Yeah, well, exactly what I drew, out of phase. I drew them out of phase. Here's the old, is this the old, no, it's not the old drawing, but I drew them and I actually showed them out of phase. So, you're just such a fucking liar.
And interference effects. Right? So if he was to, which he does endeavour to explain LIGO in interferometry, he tries to explain it in terms of photons.
No, that's exactly what I did not do. I talked about it in terms of wavelengths and frequencies, and look, it's here. Look, the previous page, it's right there. There's waves there. Well, no, that's, yeah, over here. There they are. Right there, asshole. So just keep being a fucking liar.
And out of his own mind decides that we're, without demonstrating how well, going back to basic interferometry, how we can design an experiment thinking in terms of waves. And
yes, no, you designed an experiment, and the argument is that the design has a fundamental flaw in the logic underlying it. There was a mistake made. So in the Michelson-Morley, there's a mistake made in thinking that your emitter and your reflector, and that's all each thing is an emitter and a reflector, that at any one moment, that any one photon can experience any imbalance, because it's basically a reflection is a readmission, and the readmission will be in exactly the opposite direction of the other admission, the other reflection. And whatever movement took place in the time it took the photon to travel the distance will be exactly the opposite on the trip back. The trip back undoes everything the trip forward did.
And yet the explanation for how the apparatus works is equivalent to measuring speed and distances between bullets. Frequency.
And it doesn't really matter. If I said it's the difference between the bullets, and we're talking about the bullets being redshifted, that is, the bullets being separated by a greater distance, how is that break anything? I didn't even do that, but let's say if I did do that, how would it break the analogy? If I say the bullets are blue shifted or the blue bullets are red shifted, how is in any way the idea that they're now out of phase broken? The bullets don't arrive at the same time. The bullets are supposed to arrive at the same time. They don't arrive at the same time. I can detect them not arriving at the same time. Right? Because I could just have a metal plate, and you could argue that if the bullets come at the wrong time, there's two bullets going to hit the plate at a different location, that the plate would bend, tilt this way or tilt this way if the bullets come the wrong way. So I could build a detector for bullets, and it would just detect the out of phaseness quite obviously. If they came in phase, then the thing just moves flat. I mean, how is that analogy completely corrupting what you're saying Ligos is doing? How's that break the wave or frequency, the notion of something being out of phase, which is the entire function of the device, is the phase difference? How is phase broken by the two analogies? Oh, it's not. But what my analogy does is it presents a competing argument, and that's what you don't want to hear. You don't want to hear that there's some other choice to believe something other than what you people believe. So you don't want the alternative explanation to be provided because you're wave kooks.
Now, what's required there is to show that that explanation entirely fits the design concepts of the apparatus, and that's not been done, so it can't be expected to count as an argument against interferometry.
Well, like I said, it wasn't in my argument. I didn't say it doesn't fit bullet theory. That wasn't part of the argument. So fuck you. That this is just more of your tactics. This pretense that somehow I argued a fake argument or I made a fake argument. No, I made an effort to understand your theory so I can dissect your theory. I didn't do anything else here. I didn't try to interject anything else. So you're just lying about not only my purpose, but what I actually did. I just want to understand coherently. Is the mirror moving? Are the photons moving? What the fuck is this gravity wave doing? This gravity radiation, as they describe it. This intense energy.
If that makes any sense. Right, so it's set up to look to waves. And I think this is entirely consistent with orthodox science, but it's a better way of thinking that it's not so much as that reality has this duality in waves. It's just when we set up, we can see phenomena of waves, and that's just a fact, right? Of what we count as waves. Yeah?
Right. So you could speed up human beings, right, like that documentary does. Going up and down escalators, going in and out of trains, at the subway station, the stop and go lights of the crosswalks in New York City, and you could speed that all up and you can make it look wavy. But you know that the individual people are individual people, and you know that the reasons why they're moving has nothing to do with any kind of wave function. That there's just regular mechanical flows that happen because the pressure builds, the pressure is released, the pressure builds, the pressure releases. You don't need any complex explanation beyond the fact of the elements and what the individual elements are doing. They have the properties. The individual elements are making the Rube Goldberg. The Rube Goldberg doesn't tell the individual elements how to function. It's exactly the other way around. The little elements are telling the Rube Goldberg what it's going to look like.
When we see interference type effects, we attribute wave behavior. Right? Now, it might be better to say we see emergent waves, or we see reality fooling us into thinking it can do.
Well, yeah. Well, you don't concede any of that. So that's the whole point, okay? You're emphatic that it's this nail in the coffin proof. How many people do I have to keep playing saying it's nail in the coffin evidence, this stupid Young experiment, when it's incredibly weak evidence, nothing close to a nail in any fucking coffin kind of thing. And that's your rhetoric. So yeah, you're just saying that every time there's a frequency, okay, that happens at some level smaller than bullets, things that we can't see very well, you say it's a wave. Where I say, if you made it bigger and you could see it, you'd see it's just bullets, asshole. Alright, you don't call it a wave of bullets. You really don't. I mean, they do when you scatter them around, because then it's a wave front. But I'm just saying, if I shoot bullets at one thing, bang, 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 no one calls that a wave of bullets.
Waves, or there's a fundamental wave. However, but the fact of apparent interference and We
Okay,
always construe that from.
so let's understand. Apparent interference just means there's an on-off pattern, the simplest pattern that can be created in the universe and be called a pattern. So the simplest pattern shows up, and you say every time I see on-off patterns, it's automatically can only be created by two things interfering with each other. And that's part of the what you call your orthodoxy and what I call your fundamentalism and your fanaticism. Okay, you're just every single time anything I draw, anything I demonstrate to be able to produce on-off patterns, you're going to blame it on interference. They say it right in their statements. They say, we, us physicists, know when you see that pattern, you know there's interference. And yet we know that any rational, fair-minded person would say, yes, I get what you're saying, Gary, because clearly the single slit in light doesn't match the single slit in water waves. Clearly the multi-slits in water doesn't match the multi-slits in photons. Clearly the match is just a subtle one with this two-slit thing. And it's completely imperfect in the sense that it's not creating the graduation, the smoothness of the waves. All that stuff is missing, and it should be there. So your arrogance and pomposity here. You're arguing as if you have strong evidence, and the evidence is weak. And not one of you people in all these years I've been saying it's weak evidence. Not one of you has conceded it's weak evidence. You just keep saying no, it's really good evidence. It's evidence enough for us to shut down conversation about any other mechanism being involved. We're not even going to listen. And that's what you're saying. You're saying, I don't even want to hear it. You're saying it loud and fucking clear. You endorse the videos of people who are basically saying, shut up. You have no right to have a theory that competes with our brilliant, perfect theory. I mean, you're obnoxious.
We see this interference is a big phenomenon because we can't reconcile any way that particles would cancel out. Yeah? There is no
yeah. They don't have to cancel out. All they have to do is be freaking moved a precise angle. That's all. They don't have to cancel out. So again, you can't even look at the on-off pattern and say it's a movement of 7 degrees. You can't even do that. You have to think of it as canceling. Something has to cancel out. I have to make particles cancel with each other. I can't make them move. I have to make them cancel somehow. There has to be light plus light equals dark. I have to make I have to hit 2 bullets to make no bullet hit. Yeah, no, that wouldn't be logical. But again, see, you're so myopic, you can't even imagine that there could be an explanation that doesn't have something to do with interference. You think every on-off pattern is interference.
Statistical model which can account for that behavior.
Well, I've provided that model. So again, you just discount the fact that it theoretically isn't that outlandish to say, oh yeah, there are the surfaces have electrons around them, and that there could be that where the photon goes, there's going to be more electrons over near the surfaces, and that they're going to maybe be deflected more if they're near the surface and deflected less if they go straight through. That as a generalization is a perfectly reasonable description of why it's happening, and you won't even consider it.
We control these items of reality and watch them behave as particles. Okay, slight correction as well. There was lots. But I will just make this correction.
Yeah, lots, whatever. So it's more gratuitous crap. Alright, so this part I think is going to go into something about using the analogies I was trying to use for the confinement of speed. And yes, I was incorrect to say that you could shorten the string, like when you're spinning something and you shorten the string and you make it go faster or give it more momentum. You don't. You give it less momentum. Because I wasn't thinking of the fact that Pluto moves much slower, going around, than the Earth goes much faster, and that's the distance differences. They're moving huge. Well, anyway, So I couldn't use the same analogy. But in the conversation, I'll just remind people that I use the analogy of forcing to a smaller circle. So the idea is it starts off at a certain speed, and I push it smaller and smaller, and that speed ends up getting faster. So if I could push the Earth into Mercury's orbit, that the Earth would accelerate faster. But I have to push it with an external force, not to so I can increase the velocity. You have to have something else besides the velocity getting destroyed by friction. So it has to be a perfectly frictionless contraction. So I did use two versions to try to explain the point I was making. Now, the point is an important point. So I'll go back to drawing for a second, hopefully. I hope this is not going to get fucked up. Investing too much time in this description. So can I just move this paper? I don't think I can. Let's see if it's blank on the other side. Yes, it is. Yay. All right. The argument is that in these, when these binary stars are orbiting each other, in these, especially in these weird manners where their orbits are like this, let's say. Their argument is that when they start to get close together, they speed up. And the argument would be is that they don't. That they can't do that. That the whole way an orbit degrades. Okay, so let's just say if it was a round orbit. It degrades because you lose velocity. So as you lose velocity, you start to spiral in. So your velocity gets slower as you start moving into your death spiral. And if you were to leave, that's when your velocity goes faster. Is because now you're released from. So it takes more velocity to get out and less velocity gets you in. And so when they say these things when they're close together are starting to move, half the speed of light, that means when they were first in contact with each other somehow, they had to be going close at least half the speed of light. And how do you get two things in orbit around each other going half the speed of light? How did things going that fast ever get into a system? Did they start off as protons? Is that going to be the argument, that it was two protons were circling each other? Well, they wouldn't. It'd have to be a proton and an electron. But let's say it's a proton and an electron were circling each other. And somehow they got bigger and bigger and bigger and bigger and bigger, and that's why the speed stays really high. I just don't understand how you create a system without a mechanism for creating a system that can create that much speed. And like I said, if they're going closer together, it means they're losing speed. Not only just from the fact that that's the only way they can get closer is to lose speed. You can't gain speed and get closer. So any increase in speed will make you go further away from each other, not closer. So the way these two things get closer is they have to lose speed, not gain speed. Average speed. So what point was I going to make? Damn. So the electron gets bigger, blah, 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 speed. So yeah, there's just no way to come up with this idea that somehow they get to this incredibly preposterous speed unless they came into the system with that speed, and they can't get into the system with that speed. So none of this makes much sense to me. So anyway, okay, back to, I can't just say back to, I have to change. Eventually I might be able to do this without you seeing any of the the gaps in how I'm performing. This is the one I gotta do. Okay, and I gotta move that down, and then we're back to half a day. Okay, so let's finish up and get out of town here.
Yeah, remember the other big one.
The other big one.
When you're making a slingshot, the the longer the piece of string that you can practically get up and get the speed up, the better, the higher the velocity when you release it. The shorter the piece of string, it might look like it's whizzing down fast, but and it might, because it's close to your eye, appear that it whizzes off faster with a shorter piece of string. But that's
Right. So the whole point is that you can't. The string argument doesn't work because of the string. That means that the rotational, they're all the same amount of time for one rotation. So it's the same amount of time for the rotation. Obviously, the big circle, if it has to happen exactly in the same amount of time. See, the string means it's like a steel bar essentially. So obviously, it's exactly the opposite of what you'd think if you're confining something from the external world and pushing it in. It would have the opposite effect. So that was my error. But I used both analogies. So the point I was trying to make, I think, was made, is that the velocity of these objects has to be understood, and how can they be in a decaying orbit and increasing speed. You can't increase your speed and be in a decaying orbit. You have to decrease your speed to be in a decaying orbit.
all things being equal, that's not the way it works. Yeah? For the same RPM, revolutions per minute, yeah, the longer piece ends up with greater linear velocity. What you have is angular velocities, and under consideration at the point of cutting the string or releasing the slingshot, the effective tangential linear velocity. And for the same RPMs, the further out, the greater the distance being covered per revolution, because the circumference is greater, right? And that's the way it works.
Well, I'm just saying it works depending on the force you're trying to measure and what friction you're losing. So as I used with the track guy as an example, he loses more speed to friction with the track, the tighter the arc. So he goes faster outside, in the outside part of the track, because he doesn't lose as much to friction to make the turn.
So that's just a little correction I feel in
All right, so I think that's probably enough. But you know, all of these things have subtleties to them, and they're complicated. So I'm not gonna claim I'm not gonna make some mistakes somewhere along the line, but the basic argument being made here isn't undone by that mistake. You still have to deal with what happens in the physical universe. And again, you know, the lensing argument, you know, Hofstadter's saying it's not a lens. It doesn't have to behave consistently with other lenses in the real world, when of course it does. It's the same exact mechanism. The Fresnel lens, you know, with the little lines, is kind of a perfect example of the fact that there's a principle involved. And the principle of gravity is that you can't have a whole bunch of it way out where Pluto is and then none of it where the Earth is, if you're going to say the thing in the middle is creating the gravity. That's bullshit. Steaming bullshit. Alright, so enough of a video. Hopefully there aren't too many other technical problems, sync issues and such, but we'll see. So, till next time.